Hello everyone. So we are going to start the part 3 of distillation chapter or unit. Now here in this presentation we are going to deal with the different types of equipments which are used in the pharmaceutical engineering process to perform the distillation. So without wasting any time, let's start the presentation. So see the classification of distillation method. So here actually we are having different types of method and different types of equipments which are used for the distillation. So what are they? They are basically, first of all, we have the simple distillation. So simple distillation method, it is also known as the differential distillation method, right? Next we have the flash distillation. So the flash distillation, it is also known as the equilibrium distillation. Next we have the vacuum distillation. So we all know that when we used to provide the vacuum, then we need to reduce the pressure. So vacuum distillation, it is also known as the distillation under the reduced pressure. Next we have the molecular distillation. It is also known as the evaporation distillation or short path distillation. Next we have the fractional distillation, which is also known as the rectification. Next we have the azeotropic and extractive distillation, then the steam distillation, then the destructive distillation, and finally the compression distillation. So all this type of distillation processes we are going to discuss in the upcoming slides. So for the presentation we are going to discuss the first and second, that is the simple distillation and the flash distillation. So what is the simple distillation? See, simple distillation process, it's a very common process of converting a single constituent. I repeat, for converting a single constituent from a liquid or a mixture into its vapor, right? So suppose we have a liquid. In that liquid we have one or basically sometimes two, but usually one component is present in that liquid. Now what we used to do, we will just vaporize the content or the liquid, and these vapors, after the process of heating, they will be placed to another place where they are subjected for condensation. After condensing the vapor, we are going to get the liquid back, which has finally come up from the liquid. Means suppose in a water we have added, or in a water there is some sort of component which is having a different boiling point, right? In such cases, if we perform the simple distillation, in the simple distillation what we are going to do, simply we are going to heat up the water. Once the water get heated, the vapors it will get produced. These vapor are now subjected for condensation. After this condensation, this vapor will again get converted back into the liquid and it can be easily separated, right? So this process, it is also known as differential distillation, the simple distillation. Why? It is because as distillation is based on the differences in the volatilities and the vapor pressure of the component in the mixtures. As I already told you that in that liquid, suppose in a water there is a presence of some other component, right? So the other component must have a different boiling point. So once you are going to heat that component or that liquid which is having a component, if the component have a different boiling point with that of the water, right, the component will get evaporated in a different temperature, right? So when this component will get evaporated in a different temperature, this vapor which got collected can be easily condensed to get back that component separated from the water itself, right? We are going to separate the water and the component which were initially present as a solution. So principle of the simple distillation, it is very simple, that the liquid boils when its vapor pressure it becomes equal to the atmospheric pressure. It's a very simple concept. Any liquid will boil. When it will boil, when the vapor pressure of that liquid it becomes equal to that of the atmospheric pressure. So simple distillation is conducted at its boiling point. I repeat, the simple distillation process, it is conducted at its boiling point. So boiling point of what? Boiling point of the component which we want to separate, right? So higher the relative volatility of a liquid. Now what is relative volatility? We have already discussed in our previous class. Relative volatility means the volatility of one component as compared to that of the other component which is present in a liquid, right? So higher the relative volatility of a liquid, better is the separation by simple distillation. Suppose we have a component A, right, and the water. So A has now been mixed with the water. The volatility of A is very less as compared to that of the water. What will happen? The water will immediately get evaporated and we are going to get back the component A separately. Or the component is more volatile. Suppose the component which is present in the liquid is more volatile as compared to that of the water. Then what will happen? The component will get easily evaporated and it can be easily separated and the water will be left down, right? So heat is supplied to the liquid so that this liquid can get boiled, right? And the resulting vapor pressure is transferred to a different place where it is condensed, right? So where it will get condensed, we are going to transfer this vapor to a condenser. Now this is the apparatus. So construction, what is there in the construction? Simple. It consists of a distillation flask. So this is the distillation flask. It is a simple round bottom flask made up of glass, right? So it consists of a distillation flask with a side arm sloping downward. So this is the side arm which is sloping downward, right? Next we have, it is fitted with a condenser, or condenser is fitted into the side arm by means of a cord. So this is the condenser. So it is fitted to the side arm by means of a cord, right? Now you see, the condenser is usually, I repeat, the condenser is usually water condenser, that is jacketed for circulation of water. Now what is water condenser? See, simply I am showing you in the figure. In this condenser there are two port. One, it is the inlet port. Sorry, here it is the inlet port. The water is coming here. Here the fresh water will come, and this is the outlet port. The fresh water will come. It will get revolved as per the direction. Here you see this tube. It will remain intact. This tube which is carrying the vapor, I have shown you here. This tube which is carrying the vapor, it is intact. This tube, it is intact. It is the content of the tube. It is not mixed with the water which is present in the condenser. This tube, it will remain intact because this tube, it is carrying the vapor. This tube, it is carrying the vapor. So once this vapor will traverse this path, once the vapor will traverse this path through the condenser, this vapor will get cooled down and this vapor will finally get converted into the water and it will drip down here, right? So the water, every time it will enter through this part, it will cross this part and it will again come out. So every time you need to supply fresh water to this condenser. So this is connected with a tap and this outlet, it is connected, or it is placed in a exhaust, or you can say basin, right? So now the condenser is connected to the receiver flask using an adapter. See, it is connected to a receiver flask using an adapter. So this is the adapter with a ground glass joint. So this is the ground glass joint, right? So on the laboratory scale, the whole apparatus, it is made up of glass. So generally the simple distillation apparatus, they are generally made up of quartz glass, as because via which you can easily see the process of distillation. So how it works? Simple. See, the liquid to be distilled, it is fitted here, or it is filled here. Whatever the liquid you want to distill, it is fitted here, and the volume of the liquid, it is generally keep half or sometimes 2/3 you can keep. So along with the liquid, you can also add some porcelain. Here small pieces of porcelain along with the water, it is added. Now why porcelain is added? The porcelain is added simply just to avoid the pumping. Pumping means formation of bubbles. So here you can add some porcelain pieces to avoid the bumping of the liquid which is present here, right? Next, a thermometer is inserted. This is a thermometer which is inserted, but the thing is that you should know the level of the thermometer. So the thermometer bulb, that bulb of the thermometer, the end of the thermometer, it should be below the level of the side arm. This is the side arm, right? So the level of the bulb of the thermometer, it should be always below. It should be always below than the level of the side arm here, right? Now the water is circulated through the jacket of the condenser. As I already told you, the water will come in this way, it will get circulated, it will go out, right? The contents are gradually heated. The contents of this condenser are gradually heated and it is thrown out. The liquid begins to boil after some time. This liquid, once you are giving the heat to this liquid, it will start boiling after some time. The vapor, it rises up and pass down the side arm. The vapor, it will rise up, it will pass down the side arm, right, through the condenser or into the condenser, right? What will happen now? The temperature, it rises rapidly and reaches a constant value. You need to just mark up or just observe the temperature, right? The temperature, it rises rapidly and reaches a constant value. So the temperature of the distillate is noted down. You can note down the temperature at which the distillation process has been taken down, or the vapor, the temperature of the vapor. The temperature of the vapor can be easily measured with the help of the thermometer. Why we are going to measure the temperature? Just to see whether the constituent which we are willing to separate, whether to means just to see whether the constituent we are willing to separate, it has reached a higher temperature or not. If it has reached a more higher temperature than its boiling point, what will happen? The content will get destroyed, right? So now the vapor is condensed and collected into the receiver. So in the receiver, the vapor will come down. Now the thing is that what is the rate? See, the flame here, it need to be adjusted. The flame need to be adjusted. Nowadays we use heating mantle. Here in place of this we use heating mantle. In the heating mantle, the amount of the heat need to be adjusted so that the amount of the condensed vapor which is coming out into the receiver, it should have a rate. What is the rate? Simple. The number of droplet it is coming down here. So the rate is generally kept in between 1 to 2 drops per second, not more than that. If the rate of evaporation is very high and the amount of means the liquid dripping out is very high, it can lead to the destruction in the property of the component. Thus we need to adjust the heat in such a way that the amount of the condensate which is coming in the receiver, it is less, means the rate of distillation should be 1 to 2 drops per second, not more than that. Clear? So now you see application where it is used. Simple. For the preparation of distilled water and water for injection. Water for injection, it is generally prepared by using this simple distillation method, right? Moreover, volatile and aromatic waters are also prepared by using this distillation. Then organic solvents, they are purified. Then few official compounds are prepared by distillation. What are the official compounds? These are the spirit of nitrous ether can be prepared with the help of simple distillation, as well as aromatic spirit of ammonia. It is also prepared by using the simple distillation method. So non-volatile solids are separated from the volatile liquids in this method. If we have any non-volatile solid, what will happen? The solid will remain in the flask itself. The solid will remain in the flask itself, and the volatile liquid, it will go and it will get received here. So generally we also use this equipment for separation of solids from the volatile liquids. The next method, it is the flash distillation. Now the term flash. So what do you mean by flash? See, the flash distillation, it's a process of distillation in which the entire liquid mixture which we are heating, the entire liquid mixture is suddenly vaporized. This sudden vaporization, it is known as flash. The entire liquid mixture which we want to distill, it is suddenly vaporized. How it is vaporized suddenly? We will come to know that flash means sudden vaporization. But how? When we are going to allow or when we are going to feed this liquid from a region of higher pressure to a region of lower pressure. Once you allow the liquid to pass from heated liquid to pass from a region of higher pressure to a region of low pressure zone, what will happen? More amount of the vapor will come because pressure will decrease, right? So flash distillation, it is also known as the equilibrium distillation. As I have already told you why it is known as equilibrium distillation. That is simple. The separation is attempted. When the separation is attempted using the flash distillation, the separation is attempted when the liquid and the vapor phases are in equilibrium. In the flash distillation, it is also known as the equilibrium distillation because the separation in the flash distillation is attempted when the liquid and the vapor pressure are in equilibrium. So this method is frequently carried out as a continuous process and it don't involve rectification. So principle of flash distillation, how it takes place. So simple, you see, when a hot liquid mixture, what we are having, when a hot liquid mixture is allowed to enter from a high pressure region or zone, from a high pressure zone to a low pressure zone, what will happen? This whole liquid mixture, it gets suddenly vaporized because the pressure is low, right? So this process is known as the flash vaporization. Flash vaporization means when you are going to allow the liquid mixture from a high pressure region to a low pressure region. So during this process, the chamber gets cooled. As it is vaporizing, the chamber will get cool and the individual vapor phase molecule of high boiling fraction get condensed, while the low boiling will remain as vapor. So you should remember this thing. The individual vapor phase, there will be component, right? There will be component. Suppose in the liquid you have component A, B, C, like that, right? So the individual vapor phase molecule of high boiling fraction, so those which have a high boiling fraction or higher amount or higher situation, they get immediately condensed, while the low boiling fraction will remain as a vapor, right? So this is the apparatus working, how it works. See, the feed is pumped through a heater at a certain pressure. So here we are going to feed going to give the feed by using a pump. So at a very high pressure we are installing or we are providing the feed into this heating chamber. This is known as the heater, right? Next, the liquid get heated. Yes, of course, because heat is provided here, which enters the vapor liquid separator through a pressure reducing valve. Now you see the liquid get heated. Once the liquid has passes here, it gets heated when it enters the vapor liquid separator. So this is the vapor liquid separator, right? So when this feed after getting heated, right, and when this feed is pumped with a high pressure by using a pump, then this liquid get heated when it enters the vapor liquid separator. How it will enter? Because the liquid it will pass through a pressure reducing valve which is situated here. This pressure reducing valve will reduce the pressure. Earlier it may be at a very high pressure, but gradually it will coming in a region of very low pressure, right? So when it will come or it will transfer from a region of higher pressure to a region of lower pressure, the liquid gets heated, right? So due to the drop in the pressure, once the liquid has entered in the vapor liquid separator, so there will be drop in the pressure. Thus when the liquid it will enter in that area, due to the drop in the pressure, what will happen? The hot liquid flashes, it starts flashing, which further enhance the vaporization process. So here, as it has entered from a higher pressure region to a lower pressure region, the hot liquid will flash and it will start or it will enhance or increase the process of vaporization. Thus this sudden vaporization, it induces cooling, right? Thus the sudden vaporization, it will induce the cooling and the individual vapor phase molecule of the high boiling fraction, it get condensed. As I have already told you, the vapor phase molecule the individual vapor phase molecule of the high boiling fraction. Here the high boiling fraction, they will get condensed, while the low boiling fraction, they remain as a vapor here. So high boiling fraction, they get condensed, they get separated as a liquid here. Sorry. The mixture is now allowed for sufficient time. Here the mixture will be allowed for sufficient time so that the vapor and the liquid portion separated and achieve the equilibrium. So it is allowed to remain in this vapor liquid separator for a sufficient time so that the vapor and the liquid portion separated out. So here high boiling fraction, they get condensed here, you can collect it, and the vapor, remaining vapor, it will come to the condenser now. So you see the vapor is separated through the pipe from the above. Here the vapor will be separated through the pipe from the above, and the liquid is collected at the bottom of the separator, right? So by continuously feeding into the steel, this is the steel, right? So for continuously feeding in the steel, it is possible to obtain a continuous flash distillation. We need to continuously feed into the steel so that we can attain, or we can obtain, a continuous flash distillation. The operation of, or you can say the operating condition, can be adjusted in such a way that the amount of the feed, whatever amount we are entering here, the amount of the feed, it is always to the amount of the material that is been removed. For continuous flash, what we are going to do, amount of the feed which we are providing must be equal to the amount of the product which we are getting here, right? Thus the vapor and the liquid concentration at any point, it remain constant in it. So uses, where it is used. So see, the flash distillation, it is generally used for separating components, which, I repeat, it is used for separating those components which boil at different, widely different temperatures. Suppose we have three components A, B, C. One may boil at 40 degrees centigrade, another will boil at 70, another will boil at 90. Such a huge difference we need. Means for it is only possible to use the flash distillation in separation of those molecules which have very large difference in their boiling point. So it is widely used in the petroleum industry for refining the crude oil. Advantages of flash distillation: it is a continuous process, right? As because we make it to go continuously, the amount of the product which we are getting and the amount of the feed, it is always kept constant. Disadvantages: see, it is not effective in separating components of comparable volatility. Suppose there are two components, one is having a boiling point of 50 degrees centigrade, another one is having a boiling point of 55 degrees centigrade. These are almost close, right? These temperatures are almost close, so it is not effective. This flash distillation apparatus is not effective in separating comparable volatility component. If the volatility or if the boiling point of these two components are very close, it is not effective. This instrument, it is not effective. Moreover, it is not efficient. It is not an efficient distillation when nearly pure components are required. If you want to get very pure components, suppose there is a mixture A, B, C, D, whatever it is, and if you want to get a very pure component, in such cases the flash distillation, it is generally not preferred, because the condensed vapor and the residual liquids are far from pure, because they might have some other component mix. Suppose we have the liquid, right? There we have the A, B, C, D, different types of fluid or different types of components. Now you want to get a pure, exactly pure. Suppose you want to exactly get the vapor phase should have a component only. In such cases, it is very hard to use this flash distillation method. So that's all, everyone. Thank you everyone for your patience hearing. If you like the video, just press the like icon. You can share this video with your classmates and colleagues, and for further notification from this channel, do subscribe my channel. So thank you everyone once again.